this is about another feature that 5G-MS has added in release 17, in addition to the multicast broadcasts that we were listening to, and also the event framework that we'll hear about. But this is a cross group feature. Actually, it started in SA6 and SA2, SA5 also did some work on the management, and we're in SA4, we added support for Edge to 5G-MS, and that's what I'll handle here. I'll have a few references at the end if you're interested to understand the whole picture. Again, thanks to Richard and Iraj and everyone who has contributed to the work. It has been a long journey, actually. So it started with a study item, which we called EMSA. And then this moved into stage 2 work, where the architecture has been defined, and you can see the architecture in the picture here. So basically, it's an integration of the Edge app or the SA6 architecture on Edge and the SA5 architecture on management. These two features are really, or these two architectures are integrated into 5G-MS to enable things like discovering Edge and also setting up Edge resources on demand or on need basis. What we really added in SA4 to the 5G-MS is the integration to the provisioning side, so basically extensions to the M1 interface through which the application provider can do provisioning. So it can, in addition to defining like its quality of service templates and things like that, it would also be able to define what Edge resources its sessions would require and which sessions are eligible for Edge resources. So you could say some sessions, if they meet certain criteria, they will need to connect to an Edge application server. And the Edge application server needs to meet certain requirements. So that's, in short, what this is doing. So again, everything is integrated in the MSH on the client side. So it has what we call an Edge enabler client. So that's part of the Edge app architecture. Its goal there is really to discover Edge resources by talking to an Edge configuration server and then an Edge enabler server. So once that procedure is done, so we define, for instance, we provide information over M5 that would help the EEC to discover like these Edge resources or the proper Edge application server through these the Edge 1 interface that's shown there. So it contains things like filters to limit the set of Edge application servers that meet these criteria. So the client will get a short list of servers or Edge servers that it can select from. So that's pretty much what we did. So extensions to M1 and M5. The way we did it is we separate or differentiate between two cases. One of them is the client-driven Edge session management. So in this scenario, the client is driving the session. So the client is aware that Edge resources are being used. So it requests Edge resources. Let me see if I can use this magnifier glass. So there is always like some pre-steps like application provider provisioning, for instance, indicating that certain sessions would require Edge resources. There is also like an internal like provisioning for Edge computing, Edge compute resources. So you can basically configure your data centers and spawn like new instances of the Edge application servers and so on need basis. So you could think of like always an operator always trying to keep a certain amount of edge application servers up and running for a particular application idle state and waiting for some clients to connect. So that's anticipating like some connections or some sessions to be started by the clients for a particular application. So you could have some of these resources running in idle state and waiting for connections. Then once, in this case, of course, it's the client-driven approach. So it's the application that is aware and asks for particular or discovery of an edge application server. And then the MSH will help with that. So it receives information from the AF. It can invoke like requests to the edge enabler server or edge configuration server, and then edge enabler server to discover if there is an edge server that meets the requirements. And if not, then there is this optional step. If no suitable server with sufficient like processing power and that meets the network requirements can be discovered, then the application function, the 5G-MAG AS, may decide to invoke or spawn a new instance of that edge application server, and then provide that as part of the response. So once that is discovered, basically a 5G-MAG session can continue from there. So that's on the basically on the client-driven. The AF-driven is slightly different in the sense that this can happen completely transparently to the application on the client. There might be still some assistance or some knowledge or information exchange with the MSH, but really the application doesn't know that it's even talking to an edge server. So that's all done or managed by the 5G-MAG AS based on the provisioning information that it has received from the application provider. So whenever there is an eligible session that is discovered, so all the configuration is done on the network side to set up suitable or find a suitable edge application server, and then modify, for instance, things like the DNS discovery, so that whenever the application tries to resolve location of that server, it will point to the most suitable edge application server. So we differentiate between these two use cases. Of course, in practice, probably this AF-driven might be deployed more, depending on the configuration and the collaboration scenario. So it's easier, of course, to keep this or operate this transparently from the application. It requires like some configuration on the client side, so ability, for instance, to populate the DNS cache with suitable records that would point to the most suitable edge application server. But other than that, the application doesn't really need to be aware or needs to take special precautions to operate the session. But of course, these two are enabled, and we'll see which one at the end will be more successful or will gain more traction. We also have some initial support for application context relocation. Of course, when you connect to an edge application server, there are things that you need to take into account, especially when handling mobility or like changes in network conditions, availability of edge application servers. So an instance could crash or things like that could happen. So we have defined or classified applications into different classes. So some of them can handle a relocation. They are actually unaware that a relocation has happened. For instance, if you're talking to a CDN edge, it doesn't really matter which edge server served you the last segment, for instance. So the application is totally unaware of that. And as such, relocation can be performed without risk for the application. There are other applications that are aware but and can tolerate relocations, but they have some requirements. For instance, the downtime should not exceed certain duration, things like that. So there are requirements that would need to be guaranteed if a relocation process happens. That means if the edge application server changes from one to another, and these would need to be guaranteed by the 5G-MAG before such a relocation procedure is performed. And then ultimately there are applications which are completely intolerant. So say if you're playing a real-time game or something like that, and a relocation would require that you completely tear down the previous session, start a new one. So that comes with an unacceptable interruption to the user experience, and as such, the application provider would mark these sessions as a relocation intolerant. In such case, of course, the 5G-MAG would try as much as it can to avoid relocations. Of course, there are cases where this is not always possible. Say if the data network changes after mobility, like a handover, where the UE finds itself in a different data network that the previous local data network is no longer accessible. So the previous edge application server is no longer accessible. So in these cases, unfortunately, there is not much that can be done, and an interruption is unavoidable. But these are the classifications. We also define like these criteria for relocation. And of course, we don't specify exactly how the AF would or the MSH need to operate to keep or maintain these requirements. But there are ideas like, for instance, the MSH or the AF can perform like ping operations to the new EAS or things like that, or measure like the bandwidth, the round trip time, or things like that. So before making a decision on whether to relocate to a target EAS or not. So these are all like at the initial stage in release 17, and we're expecting that more work will be done on the application context relocation and the procedures related to that in release 18. So next steps, I think there are some obvious things that would need to be done, like these client APIs. So basically extending the M6 APIs to the application to make the application aware of the edge resources, enable it also to request edge resources. So that's mainly needed for the client-driven approach. So right now it's really realized with minimal intervention from the application. Basically, the MSH takes a lead role there, but we want to enable the application to have a say basically on that. For instance, if it receives a short list of edge application servers, maybe it's up to the application to select which one to pick and things like that. Adaptivity is another topic. So being able to monitor and use the information about the status of the EAS, status of the network, and all of that can be, for instance, shared with the network, the data collection function, or it can be used to decide things like, should I relocate, should I like spawn a new edge application server instance for the future clients and things like that. So all of that would be addressed in release 18 or beyond, but also things like, are there like other edge frameworks that we need to support? What if the architecture is different than this edge app? For instance, can we operate or integrate in 5G-MS other edge architectures like 5G-MAG or even like proprietary things like Greengrass and so on? So these are questions that we'll look at in the future of edge. We'll also monitor what other groups and 3GPP are doing in the edge space and harmonize in order to come up with a solid offering for like applications and services that want to use edge features in 5G. We already started looking at such use cases, and split rendering is one of these. So it's basically enabling high complexity graphics applications to run on the edge, and then have like a relatively simpler rendering procedure on the device. So you could think of like use cases such as like remote gaming or things like that as potential applications. So you would run heavy game engines that do things like ray tracing and PBR rendering on the edge, because simply right now you cannot do these advanced graphics operations on a UE, and even if you could, this would probably be very power hungry and would not be practical on like battery operated devices. So we started a work item on split rendering. We have a concept that's called media service enablers. So we want to design this to be a form of like an SDK that application developers can use if they have like a processing hungry application that they want to split the load and delegate the load to the edge. So they could use this SDK that will perform like the rendering on the edge server. It will come with all the features needed, like discovering the edge application server, running the application there, connecting to that application and so on, negotiating formats and stuff like that. So that's one of the key use cases where we think edge would play, would be like a required enabler. And I'm bringing this here as a heads up. We might be contributing this as a use case for 5G-MAG, and we will develop a bit on, or when we make the final proposal, of course, we'll have a refined proposal on how to implement this. But this could be something that we could build in this implementation, that we could build based on a platform like Kubernetes or something like that. We will add the provisioning and the discovery interfaces like the REST APIs, and we will run a split rendering application, running a game on the edge and playing it, basically controlling it from a mobile phone. So this could be a potential use case for an implementation. And with that, I just want to point to all the specifications, or probably this is not a full list, but key relevant specifications related to edge. So as you can see, several like groups and 3GPP have been involved in this. So it's a very rich set of specifications that work together basically to provide this feature. And we hope to see this topic adopted by 5G-MAG and see how this would work in a real setup. And with that, I'll open up for questions, and thanks for listening.
Thank you.